Alright, today's video is on sketching degree angles, coterminal angles, and reference angles. So that's really our goals. There are two ways of measuring angles, and I've already put degrees and radians here, so go ahead and write that in. Degrees you're used to, you've seen those before. Radians we'll deal with in the next video. I'm going to go ahead and label this like we're on the Cartesian coordinate plane, or that's the x-axis and this is the y-axis. And so really we have four quadrants here, and we're going to label them. And each quadrant is going to be 90 degrees because the x and y axis meet at a 90-degree angle. So that creates this quadrant right here, which we'll call 1. And then over here we also have a 90-degree angle here, and so created by these two is going to be quadrant 2. Down here again, 90-degree angle. This gives me quadrant 3. We use Roman numerals for that. And then down here, this is quadrant 4. Alright, and that's a 90-degree angle. So when we're going around a circle, everyone knows there are 360 degrees in a circle. And so what that really means is halfway would be 180 degrees. Right? If I go halfway around, that's 180. All the way around is 360 degrees. So that means just if I have an angle that goes from here to here, 180, and in geometry you knew that was a straight line, so that should make sense as well. Now when I label this, I'm going to label positive in this direction. We always have sort of this definition that positive angles go in that direction, and in a minute I'll do negative angles in the other direction. So like I said before, this is a 90-degree angle. So if I open up this angle right here, this has to be 90. So straight up on the y-axis is a 90-degree angle. And that makes sense then that I'm really counting my 90s for every quadrant. If I go from here all the way down to here, that's another 90. So 90 plus 90 is 180. If I add another 90, which is this angle, all the way around from here to here would be 270 degrees. And if I keep going just a little more and add 90, I get 360, which is all the way around the circle. So 270 plus 360 is 90. So really the quadrants break up the angles from 0 to 360 into quadrants, which are 90 degrees each. All right, now if I want to go in the other direction, which will be negative angles, we can do that. All right, and so I'll do that in a different color. Going this way would be negative. We just have to kind of think, I suppose, a little backwards or the other way around. From here to here is going to be negative 90 degrees. All right, and if I just keep kind of along with the way I count in the positive direction, from here to here is another negative 90, which added on would be negative 180. Right? If I add another 90 going this way, all right, or subtract another 90 is another way to look at it, this angle now becomes negative 270 going this way. And then if I go all the way around, I could also say this is negative 360. Now I'm going to define this formally in a minute, but anytime you end up in the same spot for two different angles, it's called coterminal. So that's why 90 degrees would be the same spot going this way as negative 270 would be going all the way this way. All right, so let's move on. Oops, grabbed the wrong thing there. So if I want to draw angles in standard position, you always have the vertex at the origin. This is just the definition. You're going to have a side going along the x-axis. Again, this is x and y, this is called your initial side. And then I'm going to just make up some angle. Let's say I have an angle that's this big, and then I want it to open up from here to here. So I'm going to put an arrow saying we're going in the positive direction, and I'll put an arrow here. All right. This could be, say, a little over 90, maybe 100 degrees. And so this side right here has a name. This is called the terminal side. So whenever we draw angles in standard position, we have to have an initial side, the vertex at the origin, and a terminal side. That terminal side can end up anywhere. All right, let's slide down. All right, drawing angles in standard position. Draw an angle with a given measure in standard position, then tell which quadrant the terminal side lies. So 210 degrees, so we're going to draw this from here. All right, now when we do this, we know this is 90, We're going in the positive direction, so we're going this way. This is 180. 180 plus 90 is 270. So now I know where the terminal side is going to be between 180 and 270. We're just going to ballpark this. Vertex right here. I'm going to go ahead and squiggle this a little bit. There's your initial side. And it's going to open up an angle somewhere in this quadrant because 210 falls between 180 and 270. We're just going to ballpark it. It doesn't have to be perfect. 30 degrees past 180 is 210, so that's about that far. A little short of 45 degrees, which would be halfway for each quadrant. All right. Then we're going to go from here to here, indicating I went in the positive direction. And we're going to answer the part what quadrant we in. 1, 2, 3. 1, 2, 3. And so that's that quadrant. All right, next one. 120 degrees, but it's negative. So we're going to go in the other direction. So we'll have initial side here, which goes like that. And then now this will be negative 90. If we open up this way, we're going to go negative 90 degrees. All right. If we go from here to here, then you're going to end up at negative 180. So negative 120 falls between negative 90 and negative 180. So that's going to be about right here, which is also in quadrant 3. All right. 600 degree angle. I'm going to save this one for you guys to do in class. So this one, do in class. So your teacher will do this in class with you. All right. Let's go ahead and do negative 370 now. So negative 370. So from here, I'm going in the negative direction again. So I'm going to have the vertex here, initial side here. And then I'm going to go in this direction, negative 90, negative 180, negative 270. Got to keep going, negative 360. All right, well, if I go another 90 here in the negative direction, this will be negative 450 here. Well, clearly negative 370 is between here and here. And so I'm going to have a terminal side here. But the way we show that we went around all the way around and then some is we're going to have our arrow going this way. And then we got to come all the way around and put it all the way again to the terminal side. So we start at the initial side. We go all the way around through it and to the terminal side. Which reminds me real quick, I forgot to put my arrow in letter B. So we'll kind of backtrack here. It was negative 120. So it should be like that. All right. And then this ended up in quadrant 4. So these two ended up in the same quadrant, just a coincidence. The terminal side can end up in any of the 4 quadrants. All right. So coterminal I'm actually going to deal with later if I have enough time. If not, you will do it in class. I'm going to skip down to where it says what is a reference angle. It is the smallest positive angle between the terminal side and nearest x-axis. All right, now what do we use it for? We use it to help us evaluate trig functions. So help evaluate trig functions. And up here we often use theta with a little prime on it to indicate the reference angle. All right, so let's move along here and do these last few problems. All right. So sketch the angle theta in standard position and find its reference angle theta prime, or just a little tick mark there. All right, now I'm going to remind you here, based on the definition up there, that the reference angle is going to be less than 90 degrees. So when you answer theta prime, it should always be less than 90, and it should always be positive. All right. So you never write a negative reference angle, and you never write a reference angle that's bigger than 90. All right. So let's sketch this. So 140 degrees. So we know we have our initial side here at 0. This is 90. This is 180. Well, 140 is between 90 and 180. So this angle right here, that angle right here is theta, right? And I'm going to go ahead and write it up here. I didn't in the other ones, but it'll help us out. 140 degrees. Now the definition says that theta prime is going to be from your terminal side to the nearest x-axis, which means I want to find out how far it is in angle measure from here to here, from my terminal side nearest x-axis. All right. Well, that's simply 180 minus 140. So theta prime is 40 degrees. It's just 40 more degrees to get to 180, or 180 minus 140. That's it. All right. Now notice it's positive, and it's going to be always less than 90. All right, negative 225 degrees. So we'll draw this and figure out what theta prime is. So we got this. All right, so now we're going in the negative direction. So this is negative 90 degrees, negative 180 if we're going this way. If I subtract another negative 90, so it'll be at negative 270 here. So 225 is going to be between 180, or negative 225 is between negative 180 and negative 270. So my initial side is here. And the angle is going to end up here somewhere. And I'm going in the negative direction, so it's like that. And so this is negative 225. Well, the theta prime, or the reference angle, is from the terminal side to the nearest x-axis. Now I know these are negatives, but I just need to know the difference between these two. So I'm just going to take 225 minus 180, which is going to be 45 degrees. And so theta prime is 45 degrees. Now if you subtract these and end up with a negative, just make sure you make it positive. It always has to be less than 90 and has to be a positive angle. So if you think about it, from 180 to 225, whether we're talking about negative or positive, is a difference of 45 degrees. All right, negative 315 degrees. So we're going to go in the negative direction. Initial side's here. Negative 90. Negative 180. Negative 270 is going to be negative 360. So my terminal side is going to end up somewhere over here, where this is negative 315. This is my angle, negative 315, going that way. And so theta prime will be the difference between these two, from my terminal side to my nearest x-axis. Well, again, the difference between 360 and 315 is 45. So theta prime will equal 45 degrees. All right, again, positive. And the idea here is to always go from your terminal side to your nearest x-axis. Don't go all the way to this x-axis, because that'll be bigger than 90. So from here to here, you want to basically know the size of that angle in positive measure only. All right. All right, so clearly I'm not going to have time to do these. So in class tomorrow, you'll be taught coterminal. So we'll deal with that tomorrow, which deals with this example 2. All right, have a good day.